My name is Li-Heng Chen, and I'm majoring in electrical engineering.
I'm Genesis Luna. I'm a mathematics major, and I'm a fourth year.
I'm Joe Brozovich. I'm in civil engineering, and I'm a freshman.
My name's Rob Monsas.
Of course, I don't know.
In tons, I couldn't put a number on it, but I'm pretty sure it's a lot.
Like in dollars?
4 tons, be my guess.
Probably like 10 tons, I'm not sure.
108,000 tons of waste.
Wow, oh.
Yes. And
My guess is totally wrong.
Oh my gosh, yeah, it's crazy.
I'll guess 25 million.
I don't know. Like a couple million.
Oh my gosh, it's crazy.
Okay.
yeah.
It's a little
No.
more than what I get.
So the Green Plan Initiative is a program ran by the Office of Sustainability that's supported through undergraduate tuition funds, and that goes to supporting sustainability initiatives across campus that are led by students or faculty or staff.
The idea with this project started from us trying to automate the estimation of construction waste from construction sites. So what we focused on is trying to estimate major construction waste streams such as concrete and drywall in sites on campus, so we can better understand what happens to the construction waste and how much of it do we generate in these sites, and can we calculate those numbers automatically and how accurate are they. So in the second year of the project, we focused on better illustrating where the construction waste is being generated from, and if we can reutilize that same waste in that same project based on information on the activities that will happen from the construction schedule. So we're trying to illustrate in a very intuitive manner where this is all happening in a construction site, and where can we take advantage of other future activities in the site to take that and reutilize that waste.
So building information modeling is the digital representation of both the physical and the functional characteristics of a facility, which can be a building, a road, a bridge, or anything that is built in construction. In these models we have various types of information, such as construction materials, data about the construction activities, and also we can link this to other databases. So you can think of BIM as a big recollection of information that can guide us through a better and more intelligent decision-making process.
It was 433,000 square feet was the new piece, and it took us a little over 3 years to build it. So BIM we used extensively to simulate how a big piece of stainless steel accent piece would roll in. And so, you know, if you build it traditionally where you did the glass and the masonry first, there would be no way to install the stainless. And so we used BIM to visualize that and just confirm construction clearances, and then actually it dictated our installation sequence.
4D simulation is when you take a building information model and specifically link it to a construction schedule. So the 4D, the fourth dimension, is just time. So you literally see the construction being built over time.
This is the Navisworks. This is the software that we use to make the model 4D by connecting the construction schedule to the 3D elements. As you can see, there are some different colors that show up. The blue is the concrete that's being poured on site. The red is the rebar reinforcement that's used to reinforce the concrete, and the yellow is the wooden formwork that's used to hold the concrete during the pour. And now on the right, you can see that there are some blocks that pop up, and these represent waste that's produced from the construction of this building. So the green represents concrete that's being reused back on site later. The blue represents concrete that will be recycled but off-site. And the yellow represents wooden formwork that will be recycled off-site as well. So pink is currently showing up now as well, and this represents the installation of drywall on each floor. And once the installation is completed on the respective floors, the whole floor will turn white, and also white drywall will show up in the waste bins to be hauled off-site. Theoretically, we would like all of these materials to be reused, and the idea is to show how much waste is actually being produced and and to encourage industry professionals to think about ways in which we can reduce this waste that is being visualized on the side.
So I think that the benefits of on-site reuse are pretty incredible. It's very efficient compared to other forms of reuse or recycling, and I think that demonstrating that this is possible and giving an example of a precedent can be very useful not only for contractors moving forward, but also for engineering students and architecture students so that they can begin to think of reuse earlier in stages of design.
I inherently believe that when we're looking at waste, that we need to look at reducing first our usage of materials, right? So we need to just reduce how much materials we use on the front end. And then when we are looking at having waste materials, we need to identify what would be ways that we can recycle or reuse these materials. With regards to on-site practices, is really thinking about it from the very beginning in terms of your plan. Where can it be used? Who are my potential recycling facilities? Whether it's on the project or maybe it's someplace off-site.
I think that addressing waste at earlier stages of construction is critical. So not only addressing waste after a building is demolished, but addressing that issue beforehand so that there are strategies for deconstructing the building and preserving waste in a more complete form is important.